Alright, so on the TV screen, is record on?
Yeah.
Okay, on the TV screen, there's some information. If you will reach in the wire basket and get one bag, and if you will take out one yellow and one red of the tiniest squares, here's the thing. Just take two of them out and turn one side to red and one side to yellow. That's why you need everything else away from your area, so you've got a clear spot that you can put those on, because those are expensive and you don't want them to get lost. Because there's several $100s to replace the kit, the set, so we don't want those lost. Okay, your voice is on. Turn it off, please. Focus. Alright, so, again, what is the purpose of a model? What is the purpose of a model? Jayla. Hold up a second, because every time I try to teach, somebody's in my home. Go ahead. A model is there to build understanding about something specifically. Is a model all-inclusive? No. In other words, a model is not going to answer every question about everything connected to that topic necessarily. This model is about showing you some specific things concretely that you already know, but you need to make sure that they're very clear, because there's more to it than what we just talked about, okay? So this is building that idea. So we know that this and this represent a positive and a negative. So in your notes, if you'll write down the little yellow or tan or yellow, doesn't matter. Here's the way to remember. If the color's red, that means negative. If it's not red, it's positive. So you're going to see some things that are positive blue, some are yellow, some are green. That doesn't matter. It's just know if it's red, it's negative. Alright, so red is always going to be negative. Now I'm going to put yellow or green or blue or tan is going to equal positive. The little square has one job, and it is to represent one positive or one negative integer. One positive or one negative integer. So little square represents one positive integer or one negative integer. Write this in your notes. You find it, Kimani? You find the page? Alright, we would know that that yellow and that red are additive inverses of each other. So I'm going to write here, here's what I'm going to do to represent the little square that's red, and here's what I'm going to do to represent the little square that's tan. These are additive guys, hurry on through, please. Hurry. meaning they cancel each other out. Write that underneath there. Meaning they are zero pairs. If this is 0 and I go 1 negative and then I go back 1 positive, I have no change. If I go 2 negatives and then 2 positives, no change. Does that 0 pairing have to be at 0? Mason, does that 0 pairing have to be at 0? No. It can be anywhere. I could be on the game board at 79 and I roll 3 and then I roll -3 and I'm still at 79 because I went up 3 but I went back 3, so I'm back where I was. So no ultimate change. So that's what a 0 pair does. So -79 and +79 result in no change. They zero out. They are additive inverses. All right? They are also what are going to always represent the constant in the expression or the equation. So the little square represents the constants. Will you on your desk show me +3? On your desk, show me +3. So to show me +3, you simply turn both of those that you have over to the tan and put one more. Right? Show me -2. There's -2. Okay? You're like, simple. Yeah, it is. This is simple. Okay, only dealing with constants right now. Leave the other things where they are. You can model showing addition and subtraction and multiplication and division of integers. Now you notice I'm using the word integers because integers mean all what? You can remind me what an integer's definition is. What is an integer's definition? Fallon, what's an integer's definition? Is this an integer? -1. Yes, it is. Is this an integer, Michaela? -1/2. Answer is no. Is this an integer, Madeline? -71. Yes. Is this an integer, Zamara? 1/2. No. So all the things that I said no to, it's because they had a fraction. Integers are whole numbers and their opposites, including 0. Rational numbers are when you include all the in-between of the whole numbers. That's all your fractions. So these are only going to do integers, not fractions, right? We're only doing integers. So negative and positives without decimals or fractions. That's an integer, okay? But it's the same idea if it's a fraction or a decimal involved. All right. Now, if I wanted to show 3 minus 2, you're going 1. But I want to show you what really that's supposed to look like. So you would think, oh, that's the takeaway? Yeah. Remember what we said, a model is about showing a specific understanding. Okay, remember there's two things subtraction is about. It's about a takeaway. So I have 3 of them, I take away 2 of them, I have 1 left. That's the takeaway model, right? We want to do the other model, the difference model. Okay? We want to know the difference. That's a different model, okay? See if you can figure out how to use those algebra tiles to model this. 3 minus 2. See if you can model that for me. We'll see what you come up with. I'm going to come around and I want to see what you do. Yep, you can turn whatever. Okay, I've seen at least one person who modeled it. I see another one who's got it going. I think I see another one. All right, Lincoln, tell me what to do to model that and see if you agree.
I put 3 tan ones down.
3 tans because that represents the constant 3.
And then I put 2 reds over 2 of the
Okay,
on top of it.
but that's not takeaway, is it? Because this is the other model of subtraction. Takeaway, baby, I've got the 3 to start with, take 2 of them away, I got 1 left. That's a model. That's not this model. No, you're right. Don't back off of what you did. Don't back off what you did. I'm pointing out that that's not the model we're doing here. We're doing the other model, and that's correct, what you have. So tell us what you did. Tell us again, because I didn't get it all done. Okay, he put 2 of the reds on top of 2 of the positives. And that zeroes out, right? And that zeroes out. What's left? That. Here's why he did that. Because, agree or not, this is really this. Now, when I'm doing just regular stuff, do I put this all with it? No, but it's understood. 3, adding a debt of 2, adding -2 with it. And one negative 1 and 1 positive 1 zero out, another negative and positive zero out, and what's left is 1. So here's what that would look like if I drew it. I would say, okay, those zero out, I'm left with that. Here's how I draw it on paper. I would say plus, 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 negative, negative, zero out, 1 is left. Write that in your notes. That's how I would draw it as a model. That's what Knowledge Hook was asking you about that I said we're going to come back to. That's what Knowledge Hook was getting at. Wanting you to do it. All right, let's try the 2 up on the screen. Write the 2 on the screen in your notes. Write the 2 that are on the screen into your notes. So we've got, and if you'll write everything exactly like it is up on the TV. What do you notice about those 2 that is different, Izzy? haven't written them down yet, have you? Right, you were sitting there. What do you notice about them that's different, Izzy?
One of them, the 6 plus 3 plus 9, so it's 2 positives.
And what about the other one?
And one's negative.
So one of them is both positives and one of them is both negatives. But I'm adding in both cases. But, question, Mason, is this really adding?
Well,
It is, but we would say -2 minus 1, right? So I'm at -2, and then I'm going to go -1, so I'm going further down, right? So I'm at -2, and I'm going to go down one more, because isn't the answer to this -3 on a number line? Well, it is on the algebra tiles as well. So what would I have right here on algebra tiles? Mason, come up and show me on the algebra tiles what that would look like. This one. Show me what the second one would be like on algebra tiles. Look and see if you agree. Let me ask you this question. Is there any zero pair stuff going on in these two expressions? No. No zero pair going on in these expressions. Fallon, have you written these things in your notes? Because your notes are not open. Liam, have you written this in your notes? Have you written this down? Yes. Okay. So now we're going to write in our notes what Mason is going to show us. And I think you got it already shown. It's just on the screen. All right. So here's -2 plus a -1. And you got 3 reds. That's -3. All right. Thank you. All right. No zero pair went on there, but here's what it would look like if I had to write it out on paper. That's what I would write. Agree? Isn't that what Mason did? He put up 2 reds and another red, and that's 3 reds. Equals -3. Then we cash them out into what they are. You could literally look at this as these are chips at Dave & Buster's, and then you cash them out for whatever on a game. So if I ask you on a paper test to show me that with algebra tiles, that's what you would show me. You'd put the algebra tiles drawn under the things and tell me what it's worth. So you model it, then you convert the model into what its amount of worth is. Let me repeat what I just said. You model it, then you calculate what is the value of the model. In the value of that model, nothing's going to zero out, right? It's -3. Nothing's canceling out. What would this one look like? Kylie, you come and show me this one, please. So there's 3 positives, perfect. And another positive. So that equals what? If you write with the pen, what that's valued at. And circle that answer. And then if you look up on the TV, just to verify, there it is. And there it is. All right. All right, as we said, takeaway is one thing you do, but we're modeling the adding of the opposite, like I just said. And let's do these. Okay, so if you'll write down 5 minus +2. So this time, the negative is not the integer, but it's a subtraction sign, right? Whereas a minute ago, when Lincoln was doing it, he wasn't doing the takeaway because it was adding a negative number. You're like, same difference. It is, but it's a different model, right? So what would the model for 5 minus 2 be? Betty, you come show me that? And it would involve something physically happening, right? So what would it be, Betty? So there, she's putting up 5 positives. There's her 5 positives. Now, it says to take away what? Take away 2. Now that, you just added negative 2. But you got, your answer is the same, right? But what's it literally saying to do, though? What Betty put up there is 5 plus negative 2, but this is 5 minus positive 2, so pull away the 2 negatives. So take away 2 positives. See that? See the difference? Okay, let's do it again. Betty, this is saying, I need all eyes. 5, put your 5 back together, Betty. All right. Take away 2 positives. Now pull them away. Okay. Now, Betty, stay put. Here is another problem that's a different problem, but the same result. 5 plus negative 2 also equals 3. Now, Betty, show us that. Okay, look. Here it was 5, take away 2 positives. Now it is 5, add on 2 negatives. That 0 out. Still, the value left is 3 wholes. Right? It's just 2 ways to look at that. Okay? Right? Because that leads us to the next one. The next one is the one that kids get confused on. All right? Thank you, Betty. Okay. The next one is saying negative 4 minus negative 3. Now, let me ask you this. Are these the same? Negative 4 minus negative 3, is this the same thing? Are those the same? You're going to say clearly no, they're not. But guess what? On this problem, lots of times kids do this. Right? A lot of times on this problem, kids do this. Okay? So let me show you this. Okay, if I'm writing it, you're writing it. Correct? So, not the same. All right, let's do this first. Okay? This is negative, 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 negative. Right? Agree? And negative, negative, negative. And that gets me equals negative 7. Correct? This is saying this. Here's negative 4. All right? Here's my negative 4. And what do I do now? For this problem. I got negative 4. I've got to now what? take off 3 negative pieces, right? I'm going to take off 3 negative pieces. So I'm going to go boom, gone, gone, gone. There they are. I'm left with -1. So think of it like this. I was at -4. I'm going to go the opposite of -3, go back forward. So negative minus is going to be the same as adding 3. That's something you'll do in 7th grade. Just let me know that. You don't, if that's not 100% clear to you right now, that's okay. That's not the goal of this right now. But I'm just telling you that's what you'll be doing in 7th grade. Because there's a rule that if you subtract a negative, it's like adding that number as a positive. Because what you're saying is, I don't never burp in class. So that's saying I never burp in class. You're saying I don't never. Well, that means you do burp in class, right? It's called a double negative, like I think Nathaniel said. It is. That's right. So instead of taking off, I'm actually adding on because it's reversing it. But that's for another time. But I wanted to show you, you can still model that with an algebra tile to help it make some kind of sense of why that rule is there. We're not about that rule right now, but that's how algebra tiles can help you with that. Yep.
What about I don't eat nothing?
Well, that's back the other way.
So,
That's a true. All right. So again, literally, I took off 2, then I took off 3 negatives, and look, there are the answers. So watch what it did again. Okay, had 5 positives. I'm taking off 2 positives, and I've got 3 left. Then I got 4 negatives. I'm going to take away 3 of the negatives, and it leaves me with a -1, which is what we said. So again, here's what kids would want to do for that. They try to zero pair stuff out, but that's not what it said. I just wanted to make that point. All right? So on that one, we're just going to look at these really quickly. On that one, I'd have 3. I got a 3. But I need to take off 5 negatives. Does anybody know how in the world I'd do that? And I was just going to go on through, but we do need to dwell on this for just a second. Okay, so let me set it up again. This is going to be the last one for right now. Okay, I've got 3, but I need to take off -5. Okay, so here they are. Does anybody have an idea of what I can do? Let me make sure. Remember, you cannot change things just because they don't seem like they're what you want. Because you can in grammar, things can change, but math, they don't. A rule is a rule is a rule forever. So if I've got 3 positives and I need to take off 5 negatives, you're like, that's impossible. Jayla, it's impossible, right?
No.
What? -2. How?
Because 3 positives.
Okay, so you two come up here and show us. Betty, go with them. Okay, show us with the tiles. And turn them into positives. I've got them on red. Don't have them on top of each other so we can see them. All right. So my question is, you just put 5 negatives on there, but you can't do that. What makes you think you can? Okay, let me ask you this. If this is a balance and I throw 5 negatives over here, doesn't that do this? What could I throw on that wouldn't do that? Blank. So what is the thing that can be done that there's no change? What's the no change option? Again, this is something you've not thought about. What can I do? What can I do in math that would make no difference in the scale? Is there an addition property for 0 called the identity? Isn't there an identity property for 0 in addition? What's it say? Adding, Kylie, what's it say?
Any number plus 0
It's identity. So if I add 0 to stuff, it doesn't change the value. So if I need to pull 5 negatives off, I need to put on, listen, 5 0 pairs. So now, Jayla, put on 5 0 pairs. This would actually make you go, what? By the way, the answer is 8. The answer is 8. The answer is 8. Y'all thought you knew the answer was -2. Nope, the answer is 8. So while they're doing that, okay, well now, where's my 3 that was already there? Put it back. No. The 3 is there and put the 5 0 pairs. There's your 5 0 pairs, but the 3 still is on there. Put your 3 back on there. That's not your 3, that's 0
You're
pairs.
adding 5 0 pairs to this week.
You're adding 5 0 pairs with the 3 that were already there. There you go. Put them on there. All right, now you don't have enough. All right, so let's be clear. Here was the 3 I had, and it said I got to take 5 negatives off. Well, the only way to get negatives on there is put them as 0 pairs. Now, Jayla, can I pull away 5 reds? And what's left? 8 positives. Now, really quickly before you go to related studies, on a number line, if I'm playing a game and I'm at 3 and it says don't never go back 5, that means go plus 5. Doesn't. But in other words, what if it said here, what if it said this? Draw a card, it says go back 5, but in reverse. That's go forward 5. And again, it's okay if that, now see, look up on the screen. It's okay if that to you seems like hard to imagine. But again, remember, no math property is ever going to change. And don't you know that 0 property of addition says if I put zeros on, it doesn't change? So here's the thing. I could add infinite number of 0 pairs to anything and it doesn't change it. Because it's worth nothing. But now, have I set myself up where I can pull 5 away? So I'm going to pull 5 off. Watch. And I got 8 positives. Because minus a negative reverses that to positive. So I'm saying take away -5. Well, that means add on 5. Because it's reversing the notion. All right. If you will put the things back in the bag. You cannot leave them out while you're gone, because what will happen is your agenda will get placed on them, and then you'll flip your agenda and knock them in the floor and lose them. And we've had these for like 20 years. I don't want them lost now. So if you'll please put them back in the bag, and then if you'll please put the bag back in the wire basket. Thank you. And I appreciate the fact, Jayla, that you all were willing to go up there and think about your math, right? Because you were thinking. Does it now make sense? Because nobody in here had any reason to know that at all. That's not anything you've ever been taught. So Nathaniel, I know you knew the rule, but did you know how to do it with an algebra tile? You knew to add 0 pairs and take the 5 off? For real?
Yes, I did it in 4th.
Okay.
Yeah.
You weren't supposed to know it yet, but that's awesome if you did. Anybody else had done that before? Okay. But, again, for most of you, you're like, I've never heard of that. But now you see, that's the power of this model. Okay, so I need every tile picked up off every desk. I want you to hang on, please. We're not moving a muscle until everybody is picked up and put all the bags back in the basket.